Once again we came to chapter 5 and Thevenin equivalent circuits, usage of these Thevenin equivalent circuit in the analysis we examined in the previous video. Now we will be examining Thevenin equivalent circuit usage in synthesis. Here you are. If you look at the previous example, we are examining this usage in our example. Now this is the circuit given to us, and this is the equivalent circuit of this. So if you look at this, there is a resistor here. You might say that in here I've got 6 elements, so that means I have done this job by using 3 elements in here. So why I have used 6 elements instead of 3? The answer is this. Although that VTH is equal to 3 volts voltage source is available in the market, that RTH is not available in the market. If you go and ask for a resistor of which value is minus 375 ohm, there is no a resistor like that. Why is that? Because R value must be a positive real number, because it is the representation of physical and the chemical substance. These are real positive numbers of the material of the resistor made of. Therefore, it should be positive, that resistor value. If it is negative value, that is a theoretical value. There is no an element like that. So you're going to say that this is mathematical tool in order to calculate one of the elements in our circuit. It is not the circuit that we could realize in practice. We cannot make that circuit in practice. So this is just a mathematical tool. On the other hand, if your calculation results in a positive real number, RTH let's say, then the whole scenario changes. Then you're going to say that there is something wrong with our design in the original circuit, because you have used 6 elements in here. I could do the same thing by using the 3 elements. All these elements are available in the market. When you say that, then you can say that your design is wrong. At the beginning, the original circuit is wrong. So that is the usage of synthesis in using Thevenin equivalent circuit in this synthesis business. So once you found all the Thevenin equivalent circuit elements are available in practice, then you introduce a new design to the given circuit. So this is how it is used. Another synthesis problem important for the Thevenin equivalent circuit is the maximum power transfer theorem. So here you are. We can assume that this Thevenin equivalent circuit is representative of a complex circuit. We say has, let's say, m elements included circuit. So we are representing this circuit with a Thevenin equivalent circuit. So this is the load resistor. So if you calculate the power of this load resistor, you're going to end up with this formula. So you could check it your own. So if you get the derivative of this power with respect to RL, you're going to find out the RL value, that means load resistance value, which makes this power maximum. You end up with RL value is equal to RTH. If RL equal to RTH, then the maximum power is transferred to the load. So that conclusions why it is important, why you want to transfer the maximum power to your load. That increases efficiency of your circuit. Why is that? Because you are spending less power within your system, isn't it? If the maximum power transferred to this, that means you spend less power here. That means your circuit consumes less power in order to do its job. So how you can explain that? For example, your TV set. If it consumes less power, that means you're going to pay less to the power company, pay for the electricity. Less power, less money that you're going to pay. That's why we expect all the elements consumes or absorbs minimum amount of power. That is the efficiency of this circuit. So minimum amount of power absorbed by the circuit means you transferred maximum amount of power to the load, that is RL. That is why it is important. So this is called you might consider this is just part of a synthesis process. That's why we gave this as an example. So that is the end of the this video. The next video is going to be related to the superposition theorem, and it's going to be the last video as well.